Okay, everybody, I wanted to provide some guidance on the percent error problem. So problem 7, you need to know which of the two numbers represents the actual mass of the object and what is the measured mass of the object. And that is revealed through your knowledge of English. So it says, if a student determines that the mass of a 200-gram object is 197.55, so that reveals that the 200 is the actual mass and the 197.55 is the measured value. So with the percent error formula, you can plug everything in, calculate the answer, and you're done. In problem 8, you have to find the percent error of the calculated density. Now, of course, you should all know that density is mass over volume. You have the mass and you have the volume. So that will allow you to calculate the numerical value for the density. Now that'll work out in grams per milliliter, which is a common unit for density. There will also be problems where you will calculate the volume if the object is measured in centimeters, and it'll work out to cubic centimeters. Cubic centimeters and milliliters are the same thing. They're exactly equal to each other. But once you know what the numerical density is in this problem, you then have to calculate the percent error. Well, that means you need to know the actual density for aluminum. And if you don't happen to know that, and I just bet you don't know that because who walks around with this information, you look it up. And then you can calculate the percent error. In 9, a woman of 45 years, so she's actually 45 years old, it says that, reports that she is 5 years younger than her true age. So she says that she's 40, but she's actually 45. What is the percent error of her assertion? In 10, you have two people lying about their age, a man and a woman. You can see when the man says he's 50, that statement has a 2% error. When the woman says that she's 40, that carries a 20% error. You need to figure out which person is older. What's very common in this class is that when a formula is introduced, you almost always use it in its most basic form. That means you plug everything in and you solve for the answer that appears after the equal sign. But once you do that a couple times, I start to give you variations where maybe the final answer is known, but the value of one of the variables is not known. And you have to use your algebra skills to find that missing value. And this is a problem just like that. So you have to do this twice using the percent error formula, figure out the actual age of both of these people, and then you can answer the question asked, namely, which is older. In problem 11, you have the actual length and mass of the nail and the measured value for the length and the mass. You have to calculate two separate percent errors here. So you will do this one time using the length data, calculate percent error, and then you're going to do this a second time using the mass. And then lastly, your task, let's say, is to count out 1,000,000 peanuts, but you do it with a 3% error. So if that's the case, how many peanuts would you be off by? Now, of course, there's two possibilities. You could overshoot the million by 3%, or you could undershoot it by 3%. Either way, the number of peanuts that you're off by is going to be the same value.